Hey guys, welcome back to our CCNA routing and switching series. In this episode, we will go ahead and talk about or do a very brief overview about LAN. A lot of you already know what is a LAN. So a LAN, if I have to abbreviate, it's a local area network. So that's what, and some of the other things which are related to LAN, we're going to go ahead and take a look at in this episode. Like what are the different type of duplex? What are the different modes of communication? So let's take a look at and let's start with LAN. So taking a look at this slide, or LAN really stands for local area network. So there are a couple things that we need to really understand. It says a local and a network. So these are the two main things that you need to pay attention, and more importantly, you need to pay attention to the word LAN here. So looking at some of the definitions around LAN, a LAN or a local area network is a data network because we are talking about a data network. Now that data could be voice, video, or simple web data. The main thing about this LAN, it covers a small geographical area. So pay attention to the word again, small here. Typically a small building or a group of buildings. Even your computer or your PC at your home is part of a local LAN. Let's say you have multiple computers at your home, or you have a smart TV, or you have your phone which is connected to your wireless router. They also constitute a local LAN. Also, a LAN is a network of computer and other components. So the LAN is really not just made up of computer. It could have other components we just talked about. It could have your smart TV connected. It could have your cell phone connected. Same way when we talk about a typical LAN in an office, you might have some switches. There might be some printer, or there might be some access point if you are dealing with a wireless network. Again, the main thing that are located relatively close together in a limited area. So the whole thing about LAN we have looked up, it talked about local, small geographical area, relatively close together in a limited area. So these are some of the things that we need to pay attention. So if we have to look at some of the further things, a LAN contains two or more computers. Obviously, if you want to create a network, you need more than two types of endpoints or devices that we have seen earlier. And those two endpoints could be as simple as two PCs, or two cell phone, or two smart computers. A LAN contains two or more computers, at least one switch. So minimum one switch is required if we are talking about a wired network. And if it's a wireless network, you typically need an access point or a router which is capable of handing over or switching between the endpoints. Servers and other devices like IP phone, printers and scanner. The main thing about them, they are all connected together in one network. So the devices typically require a power supply. Obviously, if their device is not powered on, they cannot be part of a network. And most important, a network medium. So again, to connect a PC to a switch, you would need a medium. So this red line indicates a medium. And if I have to say medium, the medium is nothing but just simply a cable. Definitely some kind of cable connectors that will connect to one end to the switch and another end to your PC, your server, or your printer, or any other device. Some kind of proper software to really go ahead and create this LAN for you. So why do we really need a LAN? What are the benefits of a LAN? Again, LAN is a local area network. So the LAN has kind of several benefits actually. The main benefit, it's simplicity. So LAN is pretty easy to set up and manage, and some of the other things. Another thing about the LAN, it reduces your operating costs. How do really it reduces your operating costs? Let's say if you are working in an office, if a coworker shares the printer, if you are sharing the printer, that means not everybody in your office needs to have their own personal computer or printer. Now they all can go ahead and share the same printer. They can go ahead and share same storage device. So you could have a centralized storage and potentially other equipment. So these are some of the advantages of LAN, where you can go ahead and start sharing the resources. But at the same time, there are some drawbacks also to this LAN. Like as I've been referring, the LAN really, we are talking the local, the small, and some of the other things. So the drawback, as the name kind of really says, the LAN, its biggest disadvantage. That means it's a local, meaning it's limited to smaller area. That means, let's say if you have to connect a PC or two PCs between two cities, we cannot go ahead and use LAN in that case. And that's why the thing it says, not to mention that the network, when we say network, we are talking about the LAN here, is only effective as far as you can stretch the cable. And the cable that we use typically in a LAN is called your Ethernet cable, or a Wi-Fi signal if we are setting up a wireless network. So this is one of the limitation or drawback of a LAN, because it's really limited to a small area. Again, a LAN can accommodate only a few or even 100 of the user. So within a LAN, you can have only a limited number of PCs connected or the device endpoints connected. It cannot be too huge. So when you are working with a multiple buildings or something, usually every floor tends to have its own LAN. And there are a few more things that we need to really understand about the LAN and all. So if you take a look at this diagram, we have a small LAN, office LAN, and we do have a large office LAN. A small home business or small office environment can use a small LAN basically to connect two or more computers, and to connect the computer to one or more shared devices primarily. That's where they can go ahead and make use of the small LAN. While in case of the large office, a large office can typically use multiple LAN. So each floor can have its own LAN where you can go ahead and start connecting maybe hundreds of computers, and they can go ahead and start sharing some of those resources. So that kind of a very basic overview of a LAN. So there are a few things if I have to remember. A LAN is a local area network. It's a small. You will need some kind of a medium. You can have a wired network or a wireless LAN. It typically depends on that. There are some advantages as well as there are some drawbacks to LAN. Let's go ahead and take a look at a few more things that kind of really will help or make a baseline when we progress further into this series. Let's understand something else. So the title of the slide really says, okay, hey, half duplex versus full duplex. We just took a look here, the LAN. So LAN was nothing but a local area network where we had computer connected into a network. But regardless of the size of a LAN, the LAN has certain components. So usually the components to communicate with each other. When the components or the endpoints are talking to each other, there are few things that comes into the play. So now there are two types of duplex mode that we're going to take a look. There is half duplex and there is a full duplex. The half duplex mode, what happens? If you take a look at this particular diagram, here we have a hub. In the center we have a switch, and on this right hand side we have a PC connect. So the half duplex really says a port can send data only when it's not receiving data. That means at a given point of time in the half duplex mode, either you can send or you can receive the data. So that's what it says. In other words, it cannot send and receive data at the same time. So that means if this device is sending, it cannot receive the data on the same port at the same time. That's the half duplex. In the case of full duplex, all the nodes or the endpoints can send and receive on the data on the same port at the same time. So primary full duplex uses two pair of wires at the same time instead of single wire pair in the half duplex. So there is a single wire pair, there is a double wire pair. So why are we talking about this half versus full duplex? So as it clearly says, in the case of half duplex, if you are sending, you cannot receive. That means, let's say if there is a device which is connected behind this hub, is trying to send some data, and at the same time this switch, this PC, let's say want to send the data to a PC which is behind this hub. If this device, this PC which is behind hub is sending the data, and at the same time somebody is trying to send the data, that is not possible, because it's a half duplex. And if that is the scenario, what happens? You are sending some data and you are receiving some data, and the data is going to collide. And because the data collides, it calls a data collision, and your data collision happens. That's one of the drawback with the half duplex. But if you have a network or a media that is full duplex capable, that means at the same time you can send and receive the data without the worry of your collision. So keep these things in mind, half duplex versus full duplex. Half duplex is an old technology, a legacy technology. There might be some devices out there which might need to work on half duplex for certain reasons. But any newer device that you're working with nowadays are full duplex capable. And I would strongly suggest not to configure, not to change their duplex setting from full duplex to half duplex unless you have some strong reason to do. Let's take a look at a few more things. When you are working with any kind of a network, just like we learned half duplex versus full duplex, there are a few more things that we need to understand. There are different types of communication methods basically. So we have something called broadcast, there is something called multicast, and there is something called unicast. So as the name says, broadcast. Broadcast is simply a one on everything communication method. What this means, in this case, you want the whole network to know something and you send that information in a broadcast message. As like if you watch on the TV, if there is some special event going on, pretty much every media channel tries to share that information with you. So everybody is trying to broadcast. So that means there is a single source, and whoever the receivers or the interested party or the destination. So the source is sending the same information to all the destination at the same time, primarily. So it's trying to send the same information to all the parties which are out there. And that's what is called a broadcast. Again, broadcast, a one on everything communication. So if I have to say it's a one, there's a one source and all of these guys are our destination. And that's what the notes is. In this case, the green and yellow really indicates our destination device. And so that's where the broadcast. Multicast is also one on several communication. But there is a thing that we need to keep in mind. In case of multicast, broadcast was one on everything. Multicast is one on several. So that means we had the same sort of destination. Let's say we're divided into two groups. Let's say the yellow indicates the HR department and the green indicates the IT department. And we want to send some information to IT department. In this case, the source can selectively send that information to a set of devices. That way we are limiting that information to only the parties or the endpoint that belongs to a certain type or certain group. So this kind of communication is called multicast. Again, multicast is a one on several communication. And there are special addresses to work with the multicast. And we'll go ahead and learn some of these things later in detail. Last but not the least type of method or communication method is your unicast. In case of unicast, only a specific device is addressed on LAN. And this type of communication is also known as one-on-one communication. So you have one source and you have one destination. So in this case, the source is only sending the data to this particular destination, and that's why it's called unicast. So again, broadcast one to all. So there is a single source and it's sending the same information to all the destination endpoints out there. That's called a broadcast. In case of multicast, the devices or the endpoints are grouped into certain groups based on certain condition. Maybe they are based on their department or maybe based on their characteristic. In that case, the source is sending some information to a set of devices or to a set of group or groups. And this kind of communication is called multicast. To handle multicast, we do have a special addresses and we'll go ahead and learn those later. The third type of communication is unicast, where you have one source and one destination. So the one-on-one communication. And these are the different type of our method. Now we just kind of learned what is a LAN, what are the different duplex methods and some of the other things. There are a lot of components that really make up a LAN. Again, regardless of the size of the LAN, it could be a smaller LAN or it could be a large. A LAN typically, again, if I have to read this, a LAN is a computer network that we know so far that connect different devices. Now the different devices could be PC, laptop, switches, your access point, your printer, your smart TVs, your cell phones, everything. So the main idea behind them, so they can exchange information. Why do we create a LAN? So they can share resources, so they can exchange information. Again, regardless of its size, a LAN needs certain devices and other component. So it can really, these are some of the devices that we can see here. On the first, the LAN, the devices were like primarily Ethernet connectivity. When I say Ethernet connectivity, we're talking about the wire connectivity between the devices, where it was primarily limited to like, computers, servers, printers, and some of the other things. Again, to make up these components, we were calling host or endpoint. So host or endpoints are like a PCs or servers. And then we had talked about the interconnection. Interconnections were the cable or the NIC card sitting on our PC or laptop. Then we have something called network devices. So the network devices are like your switches, your router, and some of the other things. Again, to make up a LAN or to make up the component of a LAN, we would need again a protocol. And if you recall, protocol was a set of rules that really tells or governs the communication. So we could use different type of protocols here. We can have an Ethernet protocol. We can have an IP protocol, we can have R protocol, we can have a DHCP protocol that is running within this LAN. So all of these things really make up the LAN again. And we're going to go ahead and explore some of these things pretty in great length later on as we move forward. But one thing, if you have noticed pretty much when we were talking about a LAN, one of the things that we have been kept on seeing is this guy, which is our switch. So we kind of said, okay, hey, to make up a LAN, you would need at least 2 or more computers and at least one switch. So why really we need a switch, or what is the need of a switch? So let's talk about, but before really we understand the switch or anything, we need to understand few things or a little bit of history from where the switch came in, what was before the switch, and some of the other things. There are few things before the switches really came into the existence. We need to look a little bit into the history. We had one piece of hardware that was hub, and that device hub was a very useful piece or part of your network basically. And it was a central point where all devices would go ahead and connect just like a switch. The hub was a good device again, and it was a central piece of a device, but it had its own some of the limitations. One of the things was that hubs broadcasted everything. They received on all port except the original incoming port. That means, let's say if you have a network where you had 10 computers and somebody is trying to send a message from, let's say, computer 1 to computer 10. Now, because you are using a hub, you cannot do that. And the hub had no such thing because hub broadcasted everything. That means if PC1 wants to send something to PC10, all the rest of the 10 other PCs will also be getting a copy of that message. And that was one of the things where hub broadcasted everything. The reason the hub really worked in the half duplex mode, there was another thing that the hubs worked only in the half duplex mode. That means we just learned that. That means a port can only send or receive at a given point of time. And because they worked in a half duplex mode, there were the bigger problem of the collision. And again, the collision can happen when two or more devices were trying to send the message at the same time. And because of half duplex communication, those devices cannot receive messages at the same time. So in that case, what was happening that the messages were colliding with each other. And part of the network, we have to understand a few more things. The part of the network where these collision can occur are really called the collision domain. As the network started to grow in their size, it became really obvious the hubs are not really the sufficient devices anymore that we can rely or use on. Because now the bigger the network, we had more collisions. More the collision means more we have to resend the messages. And more we have to resend the message, could be a good possibility there's going to be more collisions again. That is why nowadays hubs are completely obsolete and they were replaced by another intelligent hub that we can say, and that intelligent hub is called switch. So nowadays switches have taken over the role of those hubs. Switches were really capable of unicast, multicast and broadcast, the message type that we have seen. There's another thing about the switches. The switches operates at the OSI layer 2, while the hub, they really worked at the layer 1. So it was on the physical layer. There are a few other things that we need to understand about switches. Because switches are operating at OSI layer 2, switches are using the MAC address. So the MAC address to really correlate the messages. And that's how they are also limiting your collision domain. Every switch that you're working with stores your MAC addresses. And again, don't worry what is MAC address. We're going to go ahead and take a look at it. So every switch stores the MAC address that it sees in its lifespan, and it stores that MAC address into its internal table. That internal table, a lot of people call as a MAC address table. So the switches are really creating and maintaining those tables so they can refer that table in the future and decide really what needs to be done from this frame needs to be sent from this PC to where and all. And because of that, they also limited the collision domain. Now, if you have to quickly talk about how this really the whole process of unicast frame works in case of a switch. So when a frame arrives, it looks at the destination MAC address of that frame. And the switch at that same time, it will take a look at its MAC address table. And if there is an entry of that MAC address table, it knows, okay, hey, this MAC address is associated with this particular port, and the packet will be sent to that particular port. If there is no entry in MAC address table, that means it's the very first time the switch is seeing a traffic interested for a party which it has no information present. So in that case, it will go ahead and forward that message to everybody except the port it received on. And that's how it will go ahead and start forwarding the packets to the rest of the port. So that's how the kind of really, the switches came into the existence. So that's the reason, we need the switches. So that's why it says, hey, when you connect 3 or more, or primarily maybe 2 or more devices together, you need a dedicated network devices to enable communication between these hosts. So in this case, if you take a look, this whole blue box is our broadcast domain. That means if let's say this PC1, PC2, and PC3, let's say, they're all part of this network and they're connected with this particular switch. So this is our broadcast domain. That means a PC1 has a capability to send a broadcast message to all of these guys. That's why all of these endpoints constitutes or makes up this broadcast domain. But now we are working with a switch. So the collision domain is limited between this PC and this particular switch. Same way the collision domain is only limited here and only limited here. And again, these devices are operating in full duplex mode. That means they can go ahead and receive the data at the same time. Let's take see there are a few more things about the switches that I think it makes sense for me to let you guys know here. As we kind of learned that the hubs were operating in half duplex, but the switches are really, operates in full duplex. That means they can send and receive the data at the same time. Another feature that a switch really gives is the bandwidth dedication. So at the hub level, all devices were sharing the same medium because it operated at the layer 1. And by means that they all share its respective bandwidth primarily. But in the case of switcher, every link, when I say every link, the link or the port between this PC1 and this switch, this particular port and this particular port. So every link shares only two connected devices, okay? That can be a switch or a PC. In this case, we have a PC and switch, or we can have a switch connected to another switch. The bandwidth will be limited only by the configuration of interface. So let's say if you configure this interface as a 10 MB, let's say switch is capable of supporting all different kind of bandwidth. If you configure 10 MB, that means you are limited to only 10 MB. But let's say if you go ahead and configure here 100 MB and here go ahead and configure, let's say 1 gig, 10 gig or 40 gig. So you're kind of limited with that. So that's another cool feature of the switches, the bandwidth dedication. Again, the switches hubs had a limited number of ports. That's why switches comes into the picture. Switches have very high port density. That means you can have switches where you can have 24 port, 48 port, 96 port. And most important part, as the switches started to grow, we started to get different kind of speeds. So you have switches that can support 10 gig, 25 gig, 40 gig, or nowadays even 100 gigabit per speed is pretty common. Again, the good thing about the switches that give the capability, let's say you are working with a building where you have multiple floors. And let's say you need to extend a LAN from one floor to the another floor. And let's say if you're working with the Cisco switches. So Cisco switches has a couple of great technology that they started supporting. One of them is primarily called as stacking. So in the case of stacking, you are connecting multiple switches together. And on the switches, you usually have a dedicated port, and that port is called your stack port. So you can go ahead and make use of the stack port, and you can go ahead and start stacking or start connecting one switch with the another switch, without compromising with your existing port or your regular port where you are connecting your devices. Create a switch cluster. If that's another thing that you can go ahead and do that. Another great thing about the switches, when the switches came in, or nowadays the switches, they have a pretty large frame buffer. And I'm saying frame. If you recall, we had talked about the different type of PDUs. And the switches are operating at the layer 2, and the layer 2, those PDUs are called a frame. That's the reason we are saying frame. So switches, nowadays the switches have pretty large frame buffer. That means they're able to store the frame for a while. So let's say if you have a PC that is very busy, you're sending a lot of data, and your switch is very busy, they have a capability to hold those frames for a while. In that case, they can send them or forward them because interfaces were, let's say, congested or something. Switches has another advantage. Switches provide something called internal switching of frames, is another benefit primarily. And that is because it operates at the OSI Layer 2 model. And again, we just looked up, they kind of make use of the MAC addresses table to do some of the thing. And because they are working at the Layer 2, so there is no de-encapsulation involved. And they can forward the packets pretty fast. There are switches that has the capability even to do Layer 3 functionality. And again, we just talked about switches also support unicast, multicast, and broadcast of the frame. So these are some of the things, that kind of really constitutes about switches, or why do we really need a switch in a network. Hopefully you guys got some idea. What is a LAN? What are the different modes of communication? The half duplex versus full duplex. Different messages that you can have, or the communication broadcast versus multicast versus unicast. What are the components of a LAN? You might have a little bit of idea, hey, what is a hub, and now why do we really need a switch? And what is a collision domain versus a broadcast domain, and you can go from there. That'll be all for this episode. I will see you guys in next episode. Thank you.